If the surest path to knowledge is science, then the shortest path to new knowledge is scientific breakthroughs. To explore scientific breakthroughs is to find theories or discoveries that challenge conventional wisdom, that change patterns of thought. In my pursuit of scientific breakthroughs, I focus on physics and cosmology, biology and neuroscience. I'm always on search for fresh perspectives of seeing the world. That's when big insights emerge, sometimes radically so. For 2 decades of Closer to Truth, my orientation is often philosophy, a way of thinking that seeks the deep essence or general nature of things. For Closer to Truth's 3 major categories: for cosmos, philosophy of physics and cosmology; for consciousness, philosophy of mind; for meaning, philosophy of religion. That's why, for scientific breakthroughs, I focus on philosophy of scientific breakthroughs. What is philosophy of scientific breakthroughs? I'm Robert Lawrence Kuhn, and Closer to Truth is my journey to find out. Here's my approach to discern the philosophy of scientific breakthroughs. I'll collect the raw data of how scientists make or view breakthroughs, then from the data, seek to induce the deep essence or general nature of breakthroughs. A place to start is with a scientist who makes breakthroughs in multiple fields. He is a physicist, a cosmologist who also works in theoretical biology and astrobiology, Paul Davies. Paul, when I think of breakthroughs in science, I think of you. You personify, to me, breakthroughs. What do breakthroughs mean to you?
Well, it's really kind of you to think of me in context of breakthroughs. They divide it really into 2 categories: the breakthroughs by the scientific community as a whole, and then those little personal breakthroughs that make life in science so rewarding. For me, I would follow the breakthroughs that were occurring during my early years and think, I'd love to work on that. But I tend to be a little bit distracted because, of course, if there's a breakthrough in another field, I think, well, I want a part of that too. And so my career has been a series of sort of going where the action is. And the reason I say I like to be a theoretical physicist and not an experimental physicist is because theoretical physics moves as fast as the speed of thought. And so I've chased after the great thoughts and the great ideas and the great discoveries. But then at a very personal level, I like to think that I have made my own breakthroughs. Now,
what are some examples?
A very early one goes under the title of the arrow of time. And so this is the familiar experience that the future and the past are very different from each other. But pinning down exactly what the source of that difference is turns out to be remarkably difficult. What is it that breaks that symmetry? It still remains a contentious issue. I like to think that I myself made a contribution to pulling that field together.
And what was that?
It turns out that you can trace the origin of this arrow of time back to the origin of the universe, that the universe was set up, we don't know how, in a rather special state. But putting all that together and bringing in gravitation, which plays a really key role in this, once you include gravitation, you realize that the early universe was actually in a state very far from equilibrium. From the point of view of gravitation, matter would like to be black holes, but it was not black holes in the early stages. Everything was very smoothed out, and it's since become more and more clumpy. So putting gravitation into the picture solved about half of the problem of the origin of the arrow of time.
What are some other breakthroughs that you've had outside of physics?
I got interested in the subject which is now called astrobiology. In the late 1980s, it was discovered that there are meteorites on Earth which looked like they had come from Mars, and people were very baffled. How did they get here? Well, we now know that Earth and Mars take a hit from time to time by asteroids and comets with enough power to splatter rocks all around the solar system. And I learned about that. I was influenced very much by astrophysicist Thomas Gold at Cornell University, and he had this, what was then a crazy idea, that life extends deep under the ground. Almost nobody believed him. But I thought, this is the type of crazy idea that I love. I took it seriously, and then I put 2 and 2 together. Well, if life exists in the rocks deep under the ground, or the rocks go splattered around the solar system, doesn't that mean life can be conveyed from Earth to Mars, say, or Mars to Earth? And maybe if life started on Mars and came to Earth, maybe we're all descended from Martians. I remember suggesting this idea in the early 90s, and nobody was going to take it seriously. But very shortly thereafter, the idea became accepted, largely because of the discovery of a meteorite in Antarctica called the Allen Hills meteorite. The meteorite has these little features which may or may not be fossilized Martians, probably not. But at the time it looked pretty exciting, and I think people felt, well, if fossilized Martians can come here, perhaps live Martian microbes can come here in a meteorite, and suddenly these ideas became accepted. In more recent years, I've become more interested in the crossover between physics and biology, the whole problem of life's origin. Where does physics leave off and biology begin, and do we need new laws to describe that? And I think that's a breakthrough waiting to happen.
Paul describes two kinds or categories of breakthroughs. Breakthroughs writ large, engaging the scientific community as a whole. Breakthroughs writ small, experienced by individual scientists. I take this dual categorization to form a first building block for constructing a philosophy of scientific breakthroughs. How to clarify breakthroughs, large and small. The sharpest case studies come from physics. I explore these breakthrough cases in physics with a philosopher of physics who works across multiple areas of contemporary physics, especially in foundations of quantum mechanics, David Wallace.
Breakthroughs happen when the framework changes, when suddenly we don't just solve new problems, we learn entirely new ways of solving problems. So you can see little breakthroughs at little levels, and then something that from a high level looks like just the continuation of science, you really see breaking down into those little steps that from the point of view of the few dozen people in the field count as breakthroughs. But in terms of like what's a level below the big ones we've all heard of, our whole understanding of quantum mechanics changed a lot in the 1980s as our understanding of what quantum entanglement was changed completely, from being this is an annoyance to this is a thing that can be used as a resource for computation, for cryptography.
You've staked out a position that would seem counterintuitive to our understanding of the world in a so-called realist approach to quantum mechanics in saying that the waveform does not break down, but it splits into many worlds interpretation. That is a breakthrough in thinking, if not an actual demonstration.
Absolutely, yes. First ideas there turned up in the 1950s. They sat quiet for decades. They really caught fire in the 1980s because the ideas that had to go with them only came on stream in the 1980s. The ideas of decoherence and how systems and environments interact and how systems and behavior can be irreversible in practice in quantum theory, even while in theory the quantum theory can carry on being reversible. Those tools had to come into place before we could really understand the many worlds version of quantum mechanics.
What are some other categories? I would think that black holes.
Well, what black holes have done for us is they're sort of the substitute we have for experiments in the quantum theory of gravity. We can't actually do experiments in quantum gravity, but we have this rather extraordinary collection of thought experiments that come out from thinking about black holes. And the reason for that is because black holes are where ideas from quantum mechanics, ideas from general relativity, and ideas from thermodynamics all come together. And they come together in a way that's incredibly hard to make consistent. I mean, really often, the way we get a breakthrough in physics isn't the brilliant way out of left field idea. It's trying to hold on to the key insights of two positions or three positions that seem on the very edge of contradiction.
Are you willing to take a risk and talk about what areas might be ripe for breakthroughs in physics in the future?
There are breakthroughs that are coming from complete surprises in the experimental science and breakthroughs that are coming from pushing the conceptual framework harder and harder. So on the experimental science side, there's one complete surprise in the last 10 years that quantum phenomena seem to be playing a role in biology that we never guessed. So the general assumption that everyone had would have been something like, well, the quantum's really important for particle physics, really important for atoms. As soon as your systems get big enough, all that quantum stuff gets washed out. Right. It seems to be turning out that, again, nature's kind of smarter than we are. and that somehow evolution has found ways of using quantum entanglement to do really key work in places like navigation, places like photosynthesis. But I think there's space there, maybe, who knows, to really change how we understand the interface of biology and physics.
Breakthroughs happen when frameworks shift. They can come via surprise results of experiments or by striving to avoid contradictions in theories. These drivers of breakthroughs form a second building block in constructing a philosophy of breakthroughs. As for the many worlds interpretation of quantum mechanics, counted as a breakthrough in thinking, but not in verification. In fact, the foundations of quantum mechanics are much in need of a breakthrough. Could trying to understand its counterintuitive weirdness be another way to develop a philosophy of breakthroughs? I asked my favorite physics writer, a philosopher as well as a popularizer of science, Jim Holt.
For decades now, there has been a debate that seems to be irresoluble among, at least for schools, on how to make sense of quantum mechanics, this, which seems to be the operating system of the cosmos. You know, any theory of physics that to be valid has to be cast in quantum form. Einstein, famously, he said God doesn't play dice. So people think he objected to quantum mechanics because it's probabilistic, because it involves randomness. That's not really true. He objected to it because of spooky action at a distance, the fact that one quantum event on one side of the cosmos could instantaneously change the state of a quantum entity on the other side of the cosmos, like voodoo. Okay, so that's one of the big conceptual problems with quantum mechanics. So there are these four interpretive schools. One is called the pilot wave theory, or Bohmian mechanics, after its founder, David Bohm. There's one that's called Everettian mechanics, or the many worlds possibility. Its founder was Hugh Everett. There is a spontaneous collapse theory, the GRW theory, and then there's kind of a Bayesian theory. Each school has proponents. These are some of the most brilliant people I've encountered in my life, and they've been arguing about it now for decades. You know, for instance, how can you believe that every time a quantum event happens, the entire universe splits into two sub-universes? That seems crazy. But a proponent of it will say, no, wait a minute. Quantum mechanics operates in Hilbert space, this infinite dimensional mathematical space of universes.
And they say that this is the most logical explanation, because you don't have to say where the probabilities are, because they're all of them. They all really exist.
Yes, but the problem is that the results of experiments in quantum mechanics are probabilities. And in the many worlds interpretation, all possibilities happen. So how does probability even enter into it? It's a deterministic view of quantum mechanics. And so the big conceptual problem for people who espouse the many worlds interpretation is to make sense of probability. And they have not really succeeded in doing this. Another question is the ontological question. If the many worlds interpretation is true, essentially what reality consists in is a universal wave function in an infinite dimensional Hilbert space. And now when we look around at the reality we inhabit, it doesn't look very much like that. It looks like a three-dimensional spatial world with one dimension of time, full of objects and people and tables and chairs and cats and dogs. How do you get that ontology out of the mathematics of the many worlds theory? So these are the sorts of really fiendishly complicated conceptual and philosophical problems that have been thrown up by the attempt to make sense of quantum mechanics, which is the best theory we have of reality. And it's going to go on forever because, once again, there's no evidence that will decide the matter.
Well, take the hidden variable idea that it seems to be probabilistic, but beneath that, there are these hidden variables, so at some level it's deterministic, which sort of bubbles up into a probabilistic way. Haven't some experiments have been negating that hidden variable theory?
No, because the hidden variables theory makes exactly the same predictions as the many worlds theory or the Copenhagen interpretation, which is kind of the minimalist interpretation. There is an interpretation, the spontaneous collapse interpretation, which says that every once in a while, a quantum system is in a superposition of different states, and when you do an experiment, it snaps into a precise reality. And so the old idea is that the very act of observation causes this fuzzy situation to resolve itself into a crisp possibility. The spontaneous collapse theory says, no, it's not the observation that causes that to happen. Every once in a while, a particle will spontaneously, like radioactive decay, will snap into a definite state, and it will drag all the particles that are entangled with it into that same state. The collapse happens out there in the world. It's not an artifact of our observation of the world. So they're asking us to make a decision about how reality fundamentally is in the absence of any observational evidence about that reality. So are we talking about science or are we talking philosophy?
While the fiercely competing theories for the foundations of quantum mechanics need a breakthrough, there seems no realistic science to provide it. What happens then? Can a philosophy of scientific breakthroughs admit non-scientific input? I ask a philosopher of mind who famously formulated the hard problem of consciousness, perhaps the paragon of problems needing a breakthrough, David Chalmers.
Here we have two of the greatest mysteries confronting contemporary science. One is consciousness. How does it fit into the physical world? What role might it play in the physical world? The other one is quantum mechanics. In quantum mechanics, we've got this experimental formalism that tells us the world is this giant wave function of superposed states, but we perceive a definite state. And the question is, how on earth does that work? There's an idea that goes back, at the very least, to the great physicist Eugene Wigner, that somehow consciousness plays a key role in quantum mechanics by being the trigger for the collapse of the wave function, the process that takes us from the world being in a superposed state, the particles are in two places at once, to a definite state. When people make a measurement, everything goes, the cat that was both alive and dead, now suddenly it's in just one state. It's alive. When does it happen? On measurement. But then you ask, what's measurement? No one knows. There's no definition for measurement. That's the problem for quantum mechanics. Wigner's idea is that somehow we make sense of measurement in terms of consciousness, and then we've got an answer to this question. When does collapse happen? As a bonus, you get an answer to the question, what is the role for consciousness in the physical world? The question at the heart of the philosophical mind-body problem. Consciousness plays the role of collapsing the wave function and making everything definite.
But on each side of the equation, quantum mechanics and consciousness, you're making a deep, fundamental assumption. On quantum mechanics, you are assuming that some sort of an active observer is necessary. And on the consciousness side, you are assuming that consciousness is fundamental as opposed to being a derivative of physical processes which have emerged. So
it's fair to say, I think, that every approach to interpreting quantum mechanics and every approach to solving the problem of consciousness has problems and is going to, probably at some level look crazy. Still, if, like me, you're inclined to believe there's already a major problem of explaining consciousness fully in physical terms, if you're led to think consciousness is fundamental, then you're faced with a problem. What is the role of consciousness in the physical world? Quantum mechanics, I think, provides a place where consciousness can do something. So if we find a role for consciousness in the physical world, maybe in collapsing the wave function, it may turn out that, consciousness somehow selects a brain state, which is in a definite state, that leads to me saying to you certain things about my states of consciousness. Now consciousness is in the loop.
when you say consciousness selects a brain state, that was a short phrase, but that was pregnant with all sorts of gigantic reality kinds of transformations.
It's like in quantum mechanics, the physical world is default state in a kind of superposition. So maybe my eyes look at the chair, my eyes go into quantum superpositions. My visual cortex in my brain is affected by my eyes, and my brain goes into a superposition. But the key idea behind the consciousness view is that consciousness never enters superpositions. It resists superposition. Consciousness has to be definite. And if that's going to make the neural correlates of consciousness go into a definite state in the brain, and that will go all the way back, it's entangled with the chair, that will collapse the state of the chair. Consciousness, by its very nature, is in a definite state. There's no such thing as being in a superposition of two different states of consciousness. So maybe consciousness somehow, by its nature, resists quantum superposition. And if it did, then maybe you'd have an explanation for how it is then that bits of the physical world end up collapsing, end up falling out of superposition. The moment consciousness gets superposed, it has to collapse. That collapses the physical world with it.
Two great mysteries. How does quantum world probabilities collapse into common world determinism? How can inner awareness consciousness come from physical particles and forces? Solve the two mysteries together as if simultaneous equations? Combine disparate ideas to catalyze breakthroughs. Another building block in a philosophy of breakthroughs. Although I see the edifice of a philosophy of breakthroughs being constructed, I begin to wonder about the likelihood of breakthroughs continuing. I am haunted by the specter raised by the book, The End of Science. I've long wanted to engage its author, John Horgan.
John, you have famously talked about the end of science. So what does that imply for breakthroughs in science as we go forward?
It implies that the really big revolutionary breakthroughs on the level of evolution, DNA, quantum mechanics, general relativity, the Big Bang model, those are over. We're going to be filling in lots of details, but we will never have a true insight into nature as profound as any of those. If you go back to the really glory days of physics, early in the 20th century up through the 70s, you had this back and forth between theory and experiment, and each was encouraging the other and verifying the other or falsifying the other and pointing in new directions that were yielding deeper insights into nature. At some point, and this was really late 70s, early 80s, with the advent of string theory and some other quantum gravity theories, you had the theorists just going way beyond any possible experiment, way beyond what can be experimentally verified. But it seems to me that when there's no experimental evidence giving you feedback, then you're not doing science anymore. You're doing theology.
It is not the science that demands observational or experimental confirmation, but it may be the only science that can do to access reality. You would cut it off?
If I'm advising young people on what to do with their lives, if they're interested in science, I tell them to stay away from particle physics and go into neuroscience or maybe cognitive psychology, which are still very much grounded in experiments and also have the possibility of resolving the mystery of consciousness or free will and things like this.
I think you're confusing the process of traditional science, which demands experiments and verification, with the scientific method and scientific way of thinking. So there may be use of the scientific way of thinking without scientific experiment and verification. I admit that's possible.
I just want to emphasize that with string theory, with quantum gravity theories, and with multiverse theories, you're not in that situation of hoping that within a decade or two, maybe the experiments will catch up with the theory. There is no hope for that. That's why I'm so pessimistic.
Pessimism may seem an odd way to end, but I like it. Pessimism sets a high bar for what constitutes a scientific breakthrough. Here are some building blocks of a philosophy of scientific breakthroughs. Two kinds of breakthroughs: large breakthroughs affecting the entire scientific community, small breakthroughs motivating individual scientists in their personal work. Breakthroughs happen when frameworks shift via experiments like quantum mechanisms in photosynthesis and animal migration, or via resolving theoretical contradictions, such as in black holes as conceptual laboratories. While the foundations of quantum mechanics need a breakthroughs, given competing theories, there seems no realistic scientific path to get one. With string theory, with quantum gravity theories in general, and with multiverse theories all the more so, experiments just cannot soon catch up. Solving two big mysteries together. Quantum world probabilities collapsing into common world events? Inner awareness consciousness emerging from physical particles and forces? Linking them surely would be a breakthrough, I'd say the biggest ever. Some scientists shun philosophy, suspecting interference in their science. But the philosophy of breakthroughs is an accelerator, not an inhibitor, helping science get closer to truth.
For complete interviews and for further information, please visit closertotruth.com.